We're here at the National Agricultural Library in Beltsville, Maryland, and we're checking out some interesting exhibits related to agriculture. Here they have an exhibit on one of America's favorite snacks, popcorn. Well, it says here that nearly all the world's popcorn production occurs in the U.S. Oh, and how about this? In southwestern Utah, a 1,000-year-old popped kernel of popcorn, it was found in a cave inhabited by predecessors of the Pueblo Indians. Huh. I wonder what they were watching while they were tossing popcorn in their mouths. Popcorn, of course, comes from corn, which is a cereal crop. And corn, along with rice and wheat, are three of the most widely grown crops in the world. Corn, wheat, rice, barley, and oat, these are all known as cereal crops, which are actually grasses that are grown for their edible grains. These crops provide fundamental nutritional building blocks for our bodies. What we're talking about here are the basic nutrients for our bodies to live, work, get energy, and avoid diseases. These grains are the backbone of agriculture, and they're critical to communities across the globe. They're also under siege from insects and diseases, as well as changing global patterns, which can alter the landscape of how and where these critical food products can be successfully grown. In this season of Science in Your Shopping Cart, we're going to take a trip down the cereal crop aisle. We'll dive into the challenges of growing popular cereal crops. We'll explore the growing popularity of ancient grains, and we'll taste a rice that's fit for an emperor. Our first stop is in the Pacific Northwest, where all that rain makes for both ideal and challenging growing conditions for wheat. When you picture America's heartland, what comes to mind? Rolling acres of wheat fields is probably at the top of your list. And that makes sense, since Kansas, North Dakota, and Minnesota are three of the top wheat-producing states in the country. But what about Washington in the Pacific Northwest? Well, believe it or not, Washington was the fourth leading wheat producer in 2022 and 23, with over 2.2 million harvested acres. So it makes sense that here in Pullman, Washington, researchers are testing and developing new varieties of wheat that are resistant to the crop's major disease threats, including stripe rust.
Stripe rust is one of the most important diseases for wheat. The disease is caused by a fungal pathogen we call Puccinia stripiformis. When stripe rust emerges and develops to a very severe level, it can completely damage the crop and reduce the grain yield by even up to 100%.
That's Xianming Chen, a research plant pathologist with ARS's Wheat Health, Genetics, and Quality Research Unit here in Pullman. Stripe rust is one of the most devastating diseases for wheat and other cereal crops. Not cereal like cornflakes or my favorite Count Chocula, but cereal crops such as barley, rye, and of course wheat. Wheat is the third most commonly grown crop in the U.S., behind only soy and corn. American farmers produce almost 2 billion bushels of wheat per year. More importantly, wheat is a staple crop for people all over the world, and stripe rust has appeared across the globe, crippling production in some areas. But what is stripe rust?
Stripe rust is a fungal disease, and the pathogen utilizes the water and the nutrition from the plants to grow fungal. It then produces the next generation of the spores, millions of the spores from one plant that affect other plants. Stripe rust damages the plants by reducing photosynthesis, which reduces the plant growth and grain yield. It is a big concern for farmers.
Stripe rust first appears on the leaves of the plant, looking like small lesions. They grow into rust-looking stripes, often yellow or light orange in color. Inside the plant, the fungus sucks water and nutrients from the plant, leaving it to die. Stripe rust can be chameleon-like because the physical pattern found on the plant leaves can be confused with other diseases, such as leaf rust, so the farmer may not know which diseases to treat. Symptoms can also vary by the type of wheat, the region the wheat is grown, and other environmental conditions. Pretty gloomy, right? But I haven't even gotten to the worst part yet.
The spores easily spread by wind and land on other plant surfaces, where they can affect other plants of wheat, barley, and some grasses.
That means stripe rust can not only affect crops on one farm, but easily carry over to neighboring farms, where it can affect wheat and other crops, including barley. So how do we stop stripe rust from spreading? Fungicide treatment could help reduce stripe rust, but farmers have to catch the pathogen in its early stages, and they have to apply the correct fungicide, which is tricky because, as I said earlier, stripe rust can appear like other diseases. It's also dependent not only on wind transportation, but climate conditions that change year to year. So one year a farmer may have little problem with stripe rust, but the next it can wipe out 80% or more of their crop.
We offer guidance to farmers on when to use fungicide and the type of fungicide and how many times. This is critical for managing this disease on your farm.
Farmers appreciate the guidance, but what they really need are new varieties of wheat that are resistant to stripe rust disease. And that's exactly what Chen and his colleagues are delivering.
This is the major strategy to control stripe rust. So we work together with breeding programs throughout the country to develop resistant varieties. And now most of the varieties grow in the United States, especially here in the Pacific Northwest, have quite good resistance. But not every variety is perfect for resisting stripe rust.
The lab here has been working with wheat breeders across the country for decades, and many of their most successful lines are still being planted today. But you can't just breed for disease resistance. It also has to have high yields, because, let's face it, what good is a variety that's resistant to stripe rust if it doesn't produce well?
For example, if we have varieties that produce 150 bushels per acre, they still want to push it to 180, 200 bushels per acre, right? So that is driving the breeding programs to assure the high yield along with resistance to stripe rust.
There are over 100 wheat varieties grown in the Pacific Northwest alone, and Chen and his colleagues constantly monitor the variants of the pathogen in wheat fields.
We cannot eradicate the stripe rust pathogen or completely eliminate it, because stripe rust not only affects wheat and barley, but also affects wild grasses. And wild grasses can grow anywhere, and they can produce spores and survive on wild grasses. So that is one of the difficulties.
With technological advances in gene identification, Chen and his colleagues can now identify favorable traits from existing varieties to help speed up the selection. He calls them markers. For example, he could choose to breed a variety that produces good yields early with one with strong resistance to stripe rust under disease-favorable conditions. What previously took a decade or longer to produce can now be developed in a few years, and the results are hundreds of new varieties with great potential for farmers. Chen notes that over the last 40 years, the average potential loss to susceptible varieties due to stripe rust was in the 30% range. That's nearly a third of a grower's plant. But with new varieties being planted by farmers here, the amount of loss has dropped to an average of 8%.
So, potential yield loss reduction from 33% to 8% is a big achievement. That's through many years of the hard work of plant pathologists and breeders. We work together to reach this goal. But if you think about it, the 8% of your loss is still very huge. How to control stripe rust even more is through fungicides. So our program also works on identifying effective fungicides to control stripe rust.
Fungicide applications can be costly for farmers, and they can also have negative environmental and health effects if applied incorrectly. Chen conducts field studies to help farmers identify stripe rust disease, how widespread the disease is, and what type of fungicide to apply.
We provide this to growers and let them prepare. Some regions see stripe rust early and need to spray fungicide. Another sees the disease late, so you can wait for a couple of weeks or a month to spray. We go to different places to check stripe rust and also develop technology, use AI, use cell phone to monitor the field and then tell the growers, oh, this is the right time to spray.
They also develop predictive field and weather models, with over 40 years of field stripe rust data and weather data. This will help farmers decide not only what wheat varieties they should grow, but whether or not and when they should spray a fungicide based on the varieties they grow.
All these tools, the fungicides, the models, and the new varieties will help farmers grow more wheat for consumers. We want to ensure that this important staple crop is available for years to come.
In our next episode, you'll learn how a tough fungus is making our sweet corn not so sweet.